All right, thank you for coming. So I am Bill Wagner, and I work on the docs team for .NET, basically responsible for all the managed languages, C#, F#, and VB. So basically, if you go to docs.microsoft.com and read anything about C#, I'm either responsible for it or wrote it. So I'm going to do something a little bit different on this one. So what I want to know right now is who is using C# 11 right now? That's kind of what I honestly expected, since it doesn't come out until November. It's in preview. Who's using C# 10? Okay. Everybody else, who's on .NET 6? Okay, so what that means is you have C# 10, but you're not using it, which is one of the things I wanted to know. C# 9 or .NET 5 in there. C# 8, 7. Okay, some of you seem to be new to C#, which is cool too. All right, so I'm going to talk more about the things that we've been really working on. A couple things that have happened with .NET since we've moved to be completely open source, cross-platform. .NET is now on a one-year release cadence. So every year in November, you'll get a brand new .NET. This year it's going to be .NET 7. Last year's .NET 6, .NET 5 before that. That was when we brought everything together, and why it skipped from .NET Core 3.1 to .NET 5, because we brought together things from Framework that we wanted. .NET Core and Mono kind of came together there. The C# language is on the same thing. So we release a new version of the language each year along with each new version of .NET. For historical reasons, we're currently on the Nigel Tufnell release, C# 11. Now, moving to a yearly release means something really interesting for a language. There are really big themes we want to work on that we don't necessarily have the time to finish and get at a high quality bar in under a year. So when we try to do that, that means a few different things that we do. We have these themes that go across multiple releases. We never really want to release like half a feature that's not really useful. So we also try to make it so that this thing that comes out in one version is useful, and we're going to add more things to it in the next version. And so I want to go back through a few versions here, and then we'll dive more into code, really going through what are the themes we're working on and what features from each release fit some of those themes. The idea being, instead of looking at each release as here's C# 11, here's a whole bucket of new features, have fun, I want to talk about how they play into the themes that we've been working on. So there's four main themes. Developer productivity in the inner loop. So we spend a lot of time writing code, running our unit tests, going back, write a little bit more code, make another unit test, add a new thing, keep moving back and forth. We want to make that as productive as it can be. So that means different things like expressiveness. How expressive is the language you're writing? Where is there friction points in terms of, oh, I'm kind of in this flow right here and I have to write it differently because of something. Let's try to remove some of those things. The second one is really related. Code readability and clarity. If I'm looking at some code I hadn't written or maintained or updated for several months, I want to very quickly be able to see what's important, understand what's there, make sense of it, and then make the changes that I need to make. The more ceremony, the more different things that are just, okay, I can ignore that, I should ignore that, I don't need to worry about this. That kind of stuff slows me down going back into reading this code. Somebody new to a project, I want them to be able to understand what the code is doing as quickly as possible. So that's the next kind of thing we really look at. The third one is really important for a language like C#. We're going to rely heavily on the C# compiler to do static analysis of your code and try to make sure that you can't write bugs. We're either going to give you warnings, possibly even errors, going, no, this is not going to do what you might think it might do, so we're not going to allow it. Or we're going to write warnings for you. I'll show you some examples of that as we move on. And then finally, there's a bucket that has features you may not use often because of what you're doing, that are very specifically designed to improve runtime performance. There's a really great online talk that Stephen Tobe gave last week talking about how we did runtime improvements in .NET 7. And he wrote this blog post that's almost 100 pages of things that improved the runtime performance of .NET. If you look at the benchmarks for ASP.NET in .NET 7, it's even faster than 6, which is faster than 5. It's one of the fastest frameworks you can do. It is because of some of these things that we put in the language that enables that. The .NET runtime is primarily written in C# now. There is less and less unmanaged code, C++ or C. It's really down into things like the garbage collector and a few other really specific, OS-specific things. And the rest of it is primarily written in C#. So the developers working on that want features to be able to make that as fast as possible. So you may not use those, but just because the runtime team is using them, suddenly your app moves faster. Like for those of you who said, yeah, I'm using .NET 6, but I'm still using an older version of C#. Yeah, your code's faster already, just because you switched your framework and you're using a runtime that uses those new features. So let's look at productivity, and let's walk through that journey from C# 8 on. So starting in C# 8, we started to do pattern matching. So we introduced the property pattern, tuple pattern, and positional pattern. You'll find pattern matching is a theme that spans several releases. We did the switch expression, which is part of a pattern matching switch expression. We introduced asynchronous streams, because a lot of programs now read things off web streams, whether it's REST or JSON or what have you, or posting things. And microservices talk to each other through these streams. We want you to be able to asynchronously for each things that come in on a stream. So you can await the next item on a stream. Because it's a stream, it needs to be disposable, so we also have an asynchronous disposable. And then one of these really small features that I like is that when we first spec'd out interpolated strings, the verbatim had to go, I think it was after the $, for no reason other than it was the quickest way, we could do it, and we'll just make one work. And then we said, okay, there's really no reason you shouldn't be able to put those tokens in either order, so let's just make it work and make developers happier. C# 9, more productivity, more pattern matching. We have type patterns. We have parentheses. We have and, or, and not in expressions. We have greater than or less than or relational patterns. We introduce records, so you can very quickly make a type that we say is a record. We have lambda discard parameters. That just means, okay, I can ignore this when I have to follow a certain signature. We have extension get enumerator support. So if you have a custom collection type or a custom type and you want to be able to enumerate across it, you can write an extension method for it. 10, there's more pattern matching. As I said, that was one of those that spans several releases. We got extended property patterns, record structs, file scope namespaces, which means I'm just going to remove some curly braces here and there. Global using directives, remove some repetition. Lambda expression improvements. A lot of times if you write a lambda expression, because they don't have types, the compiler is trying to figure out what you meant. The compiler figures it out better now. So as you're typing these things, you're not going, why is this not working? Assignment initialization and deconstruction, just a little bit of syntax. It makes it easier to mix a couple things. And then in 11, we get to another bit of pattern matching, list patterns. So you can now take a collection that comes in and say, I expect it to have certain elements in certain spots. One that kind of is both in the performance bucket and in our productivity bucket. I can take a span of char, which is a series of characters that we know is stored in a certain place, and I can pattern match it against a constant string. We have generic math support. This is one that you are going to use a lot, even if you don't explicitly go into it. If you think of writing numeric algorithms, like say you're doing standard deviation or any kind of numerical analysis, with the .NET type system, up until now, you would have to write that algorithm for every numeric type you wanted to support. Float, double, single, big int, whatever. Now you can declare through some of the support we've added, you can declare this is a type that implements the iNumber interface. So it can do anything a number can do. So I can write that algorithm once, and it will work on all those types, everything from half-size floats to float, double, long double, and so on. Which is very important for people doing things like machine learning, numerical analysis. We also have auto default structs. I'm going to demo this quite a bit. In that, what's going on, if you think of a struct, it's a type that we make, has a default value of 0. If I new it up, it has whatever my constructor says. So we made a lot more clarity about how you initialize structs and what the struct is going to be initialized to and how you can express that. UTF-8 string literals. So if you're doing anything with web protocols where the strings are UTF-8 and your .NET strings are all UTF-16, you had to do all kinds of funky things to make arrays of bytes and really long syntax, and now you can just write the string and say, yes, please, this is a UTF-8, because that's the protocol. Required members. Better way to be correct on things of data types if you want to initialize them in certain ways. All right, what about readability and clarity? C#8, we've got read-only members. I can add members to a type and say this is not going to make any changes to the object that it's working on. I've got indices and ranges. I can take any subset and I can say I just want this section of it or I want this one thing, count from either end. Null coalescing assignment. Something might be null, but I want to assign it somehow. 9, top-level statements. So we can get rid of all those curly braces, class, program, public, static, void, main, and just write the program. Okay. Target type new. Some people like var, and the var something equals new type. Some people hated var. Fine. Do type variable equals new, just open and close, and it's that type. Covariant return types. This really supports records. What it means is if I want to copy something, my return type can be of a derived class for virtual methods. Readability and clarity in C#10, global usings. Remove some of the usings out of every file in your project. File scope namespaces. We're going to get you back some horizontal space. I'll do a few things there. Constant interpolated strings. If I'm building constant strings from other constants, you can use string interpolation. Compiler will do the rest. Records conceal toString, just kind of a nice way to add some things into records. Enhanced line pragma, really just for the debugger, honestly. When source generators add source, it's going to muck with this pragma so the debugger looks at your code, not the code that got injected. C#11, raw string literals. What that does is we're going to say that any string that starts with triple quotes or more, you don't have to escape anything. We're just going to take it just exactly as it is. So if you're doing anything where you've got, say, JSON constants, XML constants, some other quoted text, you don't have to backslash this and backslash that and backslash all the other things. New lines and interpolated string expressions. If you're using interpolated strings, before C#11, the open and closing curly braces inside an interpolated string had to be in the same line. Not anymore. You can write whatever C# you want in there. And generic attributes. If your attribute needs a type, you can now make that a generic type parameter. Before you'd have to use the type of operator. Static analysis and errors. So let's fix code as you type. So nullable reference types. The compiler is going to tell you if it thinks you might be dereferencing null. It's the most important part of that. When we get to fields, what you're going to need is you need to tell the compiler if a field can be null or maybe isn't null. We're going to add static local functions. So if I'm adding local functions, I can make them static. They can't capture variables from the outer scope. The only reason you care is there's some performance implications for that. But now the compiler will tell you if you did that and you didn't intend to. C#9, init-only setters. So now I can have properties with set init. I can only set those as part of an object initialization. I can't set them later. Static anonymous functions. If we can make static local functions, why can't we make them anonymous? Attributes on local functions. Better way to do some nullable analysis there. Warning wave 5. So this is something that we've started to add where when we may be making a breaking change, what we're going to do is we're going to introduce a warning that you have to explicitly turn on to say that this part of the code might be bad in a few years. We're not sure yet, maybe. Okay. C# 10, some more struct improvements. We're going to get real clear about what a default value is and what a constructed value is. We're going to improve definite assignment. Okay. That's the feature you only notice because it works better now. So what the C# compiler does is it looks at every variable in your code as it's compiling it and decides, has this thing been assigned before I use it? Okay. As that analysis gets better, warnings about, hey, you may be using this thing you didn't assign, those get more accurate. Hey, this thing might be null because you didn't assign it, those warnings get more accurate. That is the main thing that you'll notice out of that feature. We introduced another set of warning waves, a few things that might become breaking changes later. C# 11, static analysis and errors. Extended name of scope. So now you can apply the name of operator to a parameter. That means is it's less likely that one of them drifts when you go through a refactoring and rename. UTF string literals. I mentioned before that that was productivity. It's also correctness. If I want to make something a UTF string 8 string literal and I put a character code in it that isn't valid UTF-8, the compiler will tell you, you can't make this a UTF-8 string. It's not allowed. That's not legal. Warning wave 7. Runtime performance. These are the things that get a little bit, you're less likely to use every day, but if you measure something and you find, I have a bottleneck here, these are the kind of things you might use. C# 8, disposable ref structs. A ref struct is something I want to pass some things that's kind of like memory onto the stack. We need to be able to dispose those sometimes. Unmanaged constructive types. What? So this is generic type might be an unmanaged type, meaning it's all number types or character arrays or something we know its size and we can move it around easier. I can do stack alloc in different places. So again, to avoid an allocation. C# 9, code generator performance. David's doing a talk down the hall on code generators. But what the runtime team does here with code generators is one of the really interesting bits. Like if you think of creating a regex, typical algorithms for that look at your regular expression, and then they will have an interpreted engine that runs that expression when your code runs. The .NET runtime now does something really interesting where it will look at your regular expression, and if you want it to be a compiled regular expression, it will go, aha, I can write some really fast C# code to test for that regular expression. So I'll write that and inject that source into your project, and then that's what's going to get compiled to test for a match on that regular expression. So that's a source generator. So we've got some things there that source generators need. I may need to initialize a new module. I might need some more partial methods with some different signatures. Native sized integers. So if you're doing something that gets machine intensive, and I want an int, but I want it to be the size that is the register on this process, I can now declare it that way. You'll only use that if you measure it and go, you know what, using the wrong size int, it's going to slow things down. Function pointers. So I can declare something that looks like a delegate, mostly, has a little extra star by it, and it's going to get compiled as a function pointer instead of a delegate. What that means at runtime is we don't have to allocate an object for the delegate, so it saves some memory, saves an allocation. Suppress local init flag. Don't do this unless you really know what you're doing. Reason is what .NET typically does at the runtime level is when you declare a new variable and it comes into scope, it gets initialized to all zeros. That's cool because that's safe, and we know what null does, and we know what zeros are for numbers. Let's say I have an array of a bunch of stuff. Well, it takes time to write all those zeros. If I have an algorithm and I know I'm going to put some other data in there, I can skip initializing it to 0. But you better know what you're doing because you're getting uninitialized memory that could point off anywhere if it happens to be a reference, and your program could crash. If you're going to use this, test it really carefully and use it carefully and make sure that you're actually fixing a bottleneck. And yes, the runtime team does use it and does all those things. C# 10, more code generator support. Can do a little bit more with async method builder, caller argument expressions. We now have super fast, efficient interpolated string handlers. This is another one you probably won't use directly in your code because we have some loggers and things that will make your code automatically faster. If you think of an interpolated string expression, and let's say you're writing out an entire exception trace and some other errors and more information about data when you're logging. When your log level is set to such a high level like critical only, you don't print all those things. What an interpolated string handler would do before is build the entire string, concatenate all that stuff together, make all that data, and then throw it away because we didn't write it anywhere. The runtime now makes use of some special interpolated string handlers to go on these APIs, like say logging. If I'm not going to use the string anyway, just don't even build it. If I'm only going to print out the first 60 characters to write to my log, once I get to 60 characters, don't write the rest of it, or whatever that number happens to be, which gets us noticeable improvement of runtime when we're not going to use that data anyway. Okay? And then in C# 11, we get some more code generator support. File scope types. So when code generators are creating new types, a code generator like that regex one, you may have multiple regexes in your application. So it's going to create a class that's a private class that's scoped to the source file it's in, which is generated by the source generator. That class name won't conflict with anything else in the project because it's scoped to just that file. Primarily only for source generators. We also have ref fields and scoped ref. So if you've used span of t, these two language changes mean that you can write something like span of t yourself, or that span of t is now clearly written in C# and isn't this thing that was derived from an internal, I think it was called internal ref of t. If you looked at the .NET 6 source, which the compiler went, aha, that's the thing that we know how it works. So we'll treat it special. Now it's just a pointer and an offset with a ref field, and the compiler keeps track of how it's used. Generic math will also get some performance improvements. Because you only have to write the algorithms once, code size can get smaller. The last one, improved method group conversion to delegate, is a standard change that we made that then allows the compiler not to have to allocate a delegate every time you converted a method group to a delegate. So now that the standard changed, the compiler can change, still be compliant, and we can go faster. And we don't have to allocate something we didn't need. All right, so let's look at kind of putting some of these things together and actually really see what does this mean in your code when you're actually using some of these things. And I'm going to kind of mix back and forth between some of the different releases, but let's look at some of where the code goes and the kinds of things we can do. So of the people that are using different versions, who is already using nullable reference types? Has it turned on in your project? Okay. So let's start by looking at a couple examples of working with nullable reference types and what it means. So let's go ahead and just add my what's new space there. All right, so if I go into my examples here for these, all right. So here I've got a couple different, this is a common algorithm one might have where I've got some kind of linked list of stuff because I'm often inserting things here, there, and somewhere, and I want to enumerate it. So this would be pretty reasonable code. I grab the head of the list, and while that particular node isn't null, I'm going to just write some stuff out, and then I'm going to go to the next node, and that's totally reasonable. And if you notice, I have this set as to implicitly typed. What the compiler does with nullable reference type is that this is actually a node question mark, a nullable type. And the reason it is because this is a local variable. The compiler's static analysis can really accurately determine if you ever dereference null. So for instance, if I take this off and say this is now a non-nullable reference type, I now get a warning there on that node.next. And the reason I get that warning is this type, because a linked list has to end somewhere. It's a record, so it's got an ID. I just put that in just for this demo. And the pointer to the next thing could be null, right? Because the list eventually ends. It doesn't go on forever. But so by making this either a node question mark explicitly to be this could be null, or by making it an implicitly typed variable, which is definitely a a nullable type, then we get the warnings we want. If I were to do something here, like take that console.write line, and if I were to, to try to write node.id, okay, now I'm getting a warning. The reason I'm getting the warning is I'm trying to dereference null. Okay, so the way we want to think about nullable reference types there is, nullable reference types is primarily a feature for the compiler to say, you might have dereferenced null here. We should fix it. There's nothing wrong with a reference type variable having the value null. What's wrong is when we dereference it and then crash. Now, where that gets to something like, if I were to say I have a person type, or if you look, I'm now getting warnings here because, I've said it's a string. Both of those properties are supposed to be non-nullable. Well, and with just gets and setters, I can't, the compiler's like, well, you may not have set those. Who knows what that could be? So I have to do some things there where I talked about some of our other features where I could say, this is an init, and that's an init. Okay, that didn't quite fix it. I'm supposed to only initialize this. But, somebody up there like that new person, I could just, copy this or just say another line. I could just say p equals new person and skip the initialization, and well, it's just there, okay? Well, in C# 11, we now said, I'm going to say this is required. You have to set this. And that's required. You have to set that. Aha! Okay, now I get an error up here where I tried to create the new person because I did not set the required properties. The class designer right here says, you have to set these. You are required to set them. Okay. I didn't set them up there, so that line won't compile. In order for it to compile, I would have to once again go, okay, I want to set the first name. I'm going to cheat here because I really wanted the defaults, and I'm going to set the last name, and I really wanted the defaults there too. Let's see. Oh no, compiler says, no, those are strings. Those are non-nullable reference types. You don't get to set them to null. Okay. Here where I want to be careful about how we talk about required members. If I say this required member is nullable, notice how the green squiggle went away up above. If null is a valid value, I can initialize a required member to null. Okay? So those things can travel in pairs if we want, and they help make those things better. So, what is the init doing? Okay, so if I say this is an init only property, after I have set this first name, last name, now the person wanted something different. p.firstname equals, wants to go by his full name. Okay, that's not going to compile. The reason it's not going to compile is because I said that was an init only property by saying it's init. So I can only set it when I'm doing one of those object initialization. Okay? Yes?
Part of the init, that also would mean you could not use it, like set it in the constructor as well, or?
Can I set an init only property in the constructor? Yes, I could. Okay. So I could write a second constructor for this type here that took a first name and last name parameter and set the properties. So I can set it either in a constructor or in the using object initialization. Either one of those work just fine. Okay? Anything else there? Okay. Now, I kind of alluded to in that first example, the record. So let's look at this here if I want to do a couple things here. Now, I'm going to say this is a record. Okay? Now, the reason I want to say that's a record is if I think of something like a person object, what I would want to do is say, you know, two person objects are equal if they have the same name. Or if I have more properties, same name, same age, same, you know, Social Security, government ID number, whatever it happens to be. Okay? As a class, two person objects are equal if they refer to the same object. Okay? So when I say this is a record, now two records will be equal if they have the same properties. The compiler generates all the code to test for equality, test for inequality, test for, or generate a hash code, also generates a toString method, and it does it in such a way so that if I were to make a derived class from that person class, the derived class would generate new versions, including a copy constructor that preserves the correct type. Okay? So if you want to think of using a record, anytime you want to use a record class, anytime you're building a hierarchy where what you want is value equality up and down the hierarchy, that's a record. Okay? Now finally, if I look at something like this and I say, you know, as a record, I really want, you know, you may as well just construct it. If all it's got is just this get and init thing, I might do something like, say I have a string here, first name, and string last name. And if I just put the semicolon there, I don't need any of this stuff. Okay, and now I just have to change this to be that. Boom, 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 boom. Okay? And that's now called a positional record. So what we've said is we've given those properties positions. The compiler will now also generate the properties for them. I can mix and max position and initialization. If I want to add something here, I can then also say we have a public string question mark. Some people have a middle name and some don't. And I can say that's a get and init property. And I could add any other methods I did want in a positional record, whether they be properties, computed properties, or methods, what have you. Any of those I can add. Okay? So effectively what record gives you is you have a more convenient syntax to say, I want value-based equality among two different types. And now let's look at patterns. This is probably the one I think changes the way we think about code the most. So let's go here. No, it should not be there. Okay, so first let's clean up this a bit. So as I said, I've got this namespace here. It's got the curly braces. And I said we have these file scope namespaces. I love the way Visual Studio does this. If I put a semicolon right there, it's a file scope namespace. Notice it removed the curly braces and outdented everything 4 spaces for me. So there you go. I just made that refactoring. Awesome. Now if I'm here, why is that one not there? All right, I typed something wrong on this one then. All right. All right. Oh, fine. With top-level statements, I cannot have a type before more code. So I had to move the record down. Okay. This whole program is using top-level statements. So basically what you can think of that is, other than the using, everything in here is like the insides of your static void main that's familiar to everyone. All right. So if we look at patterns, we'll start here with type and positional. So let's say I wanted to do something like, I'm getting some input strings. It might be a string. It might be an array of characters. It might be a list of characters. It could be something. I want to get the first 5 characters out of it. Okay? So I'm going to just test some types and test the properties of it. So if I have a string, here's how we can read these. This is a switch expression. Okay? So I'm going to look at my input, which is an object, and I'm going to switch on it. And if that is, the type is a string, and the length property of that string is greater than or equal to 5, I am going to return the substring from 0 to 5. Okay? Let's just make that a range pattern, just because that would be more fun. Let's just go. And I think that would actually change the output type. If it is a string who's less than 5, well, this would be bad. So I'm just going to say, otherwise it's just a string, just return the string. Now, if it is a collection who's got a length, I'm going to say, all right, if its count is greater than 5, then I'm going to return something that looks like it's a new string from those symbols. I'm going to take the first 5 and I'm going to convert it to an array, so I get an array of characters, and I'm going to create a string out of it. And if it's an I collection of char, and it may not have as many as 5, take the whole thing and make it an array. And notice I'm also introducing a new variable here. So that I collection of char, if it matches that property, I'm going to assign it to symbols. Okay? So I've got this input thing that's coming in that I don't know much about. These different things on the left of that lambda arrow are patterns. Does the thing that came in match whatever properties I've given it? Okay? If we were to write this before pattern matching, this would be a series of nested if, then, else, fireman's ladder things in and out and back and forth and so on. So pattern matching says it's going to be one of these kinds of things. Let's do something. Toward the end, I have a null. If it's a null, well, you passed me something bad, so I'm going to throw an argument null exception. If it's anything else, I'm going to throw an argument exception and say this is just not some type I wrote code for yet. All right. Other pattern types we have, we've got our relational patterns. So if I got a number, I've measured some value of something, and depending on where it is in the range, I'm going to say it's either too low, it's nice, it's acceptable, it's too high, it's way too high. I have no idea what this is because it's not even a number. Okay, so I've hit the whole set of possibilities here. And it's just going to test these in order. Again, could be written with an if, then, else, so on and so forth. But this is just a little bit clearer to read. And I'm using both a relation and I'm using those conjunction patterns and an or and so on. We can do the same thing as another example, taking something with dates. Am I in the months that are spring or summer or autumn or winter in the northern hemisphere? Once again, I'm looking at discrete values of my input value, the date.month, and I'm saying what I wanted to write out. Okay. So once again, patterns give us a thing to really look at a different way to write code that was always imperative. If test something, do something. If test something else, do something else. If test something else, do something else. So on and so forth. And now I'm going to say, let's take this input. Let's look at different things we can do with it. Look at what it looks like. And then say what we're going to do. And finally, I want to use something with a list type of thing. So let's say I'm processing some kind of a CSV file. So it looks something kind of like this, right? I've got a date. I've got whether it's keyed as a deposit or a withdrawal. I might have a memo field in it. I might have some extra notes from the person who wrote a check. I might have then a value at the end. Okay, and I want to process these in order. This is going to look like a list pattern. So I'm now going to say, all right, I got some kind of an array here. I've got the date, which I don't care about, so I'm going to use the underscore and say that first field, I just don't care what value it is. I'm going to have deposit, withdrawal, interest, or a fee. And then I've got something I really don't care much about. on some of the occasions with the deposit, with the withdrawal, I may have multiple fields. So I'm going to have this dot dot that says there's one or more things written here that I don't care about. And then at the last thing in this list from the CSV file, I'm going to have the amount that I'm actually going to be doing something with. So then I'm going to process that based on what type of transaction it is and what the amount is. And I don't care about the other fields. So I've taken a list pattern, which says I've got this collection, this list of things, and the things I don't have, well, I'm just going to not care about them. Okay? Any questions in general about some of the new features that we've been doing? You can play with some of the code a little bit, and I've got a bonus demo if we have time.
So this is, if I'm understanding correctly, what you're doing is that you're basically pulling out into a method a switch case.
Mm-hmm.
So that I can use that, I can write that method
Yep.
to use the switch case to actually check for patterns.
Yes. Yes, we're giving you a much richer syntax for switch. Now, we've also made it an expression rather than statements, right? So instead of just case this, case that, you have this whole thing. And then the right side of that lambda arrow is an expression that sets some value, okay? Could be calling a method that returns a value and so on, but yes. Yep. Anything else? Yes.
So this is all in net 7, or could you use this in net 6?
Everything except for the list patterns is in net 6 that I showed on pattern matching. The only new patterns for C# 11 is the list pattern, this final one here. Yep. Mm-hmm. Okay. Last bonus thing of something that we're kind of experimenting with. There are some of this that's a bit in preview, where we're going to take C# and put it into other different places. So this is in VS Code, and this is running a C# interactive notebook. So is anyone here familiar with Jupyter notebooks of any kind? Okay. So now you can put some dotnet in your Jupyter-style notebooks. So I can mix a tutorial here that was working with LINQ, and I can make cells that are C#. So it's going to load a set of values, and we're going to define, say, a deck of cards, as suits, and an enumeration for ranks. For the rank, ace through king. I can build a whole deck of cards, and then I'm going to explain some different things about some stuff I'm going to do with LINQ. So let's build a whole deck of cards by generating some things, by saying I'm going to enumerate all the suits, I'm going to enumerate 2 through ace, and then I'm going to create a new card. All right, that's cool. All right, so now .NET Interactive can generate a deck of cards. And now, if I want to display the deck, now here's where notebooks get really powerful. If I wanted to write a full program for this, I would have to do all kinds of XAML and WPF things and put it in place. And here, this is, if you look, I've got a formatter that's going to be able to display a deck. It's got a view that's going to be a div in this notebook. And then I'm just going to display, I've got some ping images here for a deck of cards. And I'm going to say, yeah, it's going to be that file, and just display it and write it. So if I run this cell, now what I get, let's run our cell. There we go. And now I get a deck of cards displayed here. Okay. So as a teaching tool, I can use any kind of interactive display here. If you're familiar with Plotly or any other JavaScript package, anything that works in notebooks, I can do it. So now we can start to, let's shuffle the deck. We'll split it in half, and then we'll take the top card from each of them. And let's see how many times it takes to shuffle them to get them back in their original sequence. And then let's build our deck again. Okay. And now let's start shuffling the deck, and let's see what happens each time it shuffles. I'm even doing some async stuff here so you can see each iteration. So we had the deck, now we started to shuffle. You see the 2s and the 8s come in, and different suits come in, and cards are moving around, and I keep shuffling. And thankfully I did this in a way that it doesn't take too many shuffles. And then it's back in order. Boom. But you get to see that visually. So we can start to play with this, and we can do things inside notebooks where you can explore data using C#, mix Markdown, mix CSVs, whatever other kinds of cells you have. You can store the results of each cell. So if I were to save this notebook now, it would save the images and the HTML that was generated from each cell's output. And you can start to explore data and build some algorithms inside a notebook, and then take those into different places. And with that, that's kind of the big thing I wanted to get to in terms of our, the journey we're on with C#. New version will come out in November. You can learn more here, where I keep writing about all the new features, see them more as to what's available in each version. And I will be here and around for answering any other questions as you get going. And I'll be around for lunch, and enjoy the rest of the conference as well.